Okay, I already went through this once, but you can see this is take 2 because the hovercam decided to freeze and delete everything. So I'm going through this again. Hopefully it'll be a little more concise this time. Alright, we're doing 23-2, properties of logarithms, and our review fact is the log base b of y is equal to x if y is equal to b to the x. Alright, the previous section was about finding inverses. Alright, and so this is kind of taking a step back away from inverses and just saying these two things are equivalent. Alright, this log statement and this exponential statement are the same. Right? If they were inverses, we'd have to flip our x and our y, and then they would be inverses. So that's always your first step when you're finding inverse, is flip the x and the y. All right. So what we're going to do is we're going to do our three things. 1, 2, 3. The first thing is we're going to go from exponent to log. All right, and that is like 3 to the power 4 is equal to 81. That is an exponential statement, and so we want to say what kind of a log statement would that be? So bx is equal to y. So our base is log base 3. All right, and then of 81 is equal to 4. And that's just matching pieces up. So the x, which here was our 4, goes on the other side by itself. The y, which was by itself here, is what is our log statement, log of 81. And then the base is the base. So base of our exponent, base of our log. All right. If we had 6 to the negative second power is equal to 1/36, that would be log base 6 of 1/36 is equal to -2. So we took these two exponential statements and wrote two log statements. All right, that's the same thing we did last unit, except they were all base 10. All right, and so all we're doing now is we're adding in the fact that it's not base 10, it's different bases. All right, then the next thing is from log to exponential. So if we have the log base 4 of 16 is equal to 2, all right, and this is where this little circle really comes in handy. 4 squared is equal to 16. 4 squared is equal to 16. And that, for me, going from a log statement to an exponential statement is the easiest. You just take the base, there, there. Super easy. All right, log base, let's do log base e to the power of 1 is equal to 0. All right, so e to the power of 0 is equal to 1. E to the power of 0 is equal to 1. And what we're going to see is the actual way that you're supposed to write log base e. Log base e should be written as just ln. All right, natural log. All right, so really this is equivalent to ln of 1 equals 0. ln of 1 is equal to 0 instead of log base e. All right, they're the same thing. That's why I write equals here. Those are the same thing, just more commonly it is written here. Just like when you write log, it's assumed it's base 10. If you write ln, you understood that the base is 2.7. All right, the third thing that we did, so we went from one direction to the other direction to that one. You know, these are flip-flop of each other. The third thing, which everyone messed up on our test, is evaluate. All right, which evaluate just means solve. All right, it means write an equal sign, and what is it? All right, I kind of wrote that in the way, so we're going to have to solve down here. So let's see, log of 2, log base 2 of 32. What does that equal? All right, and you can put it in the calculator, but we're trying to do this. We're trying to do it without the calculator. All right, so I like to go ahead and do kind of here and say, okay, well 2 to the power of something is equal to 32. 2 to the power of x is equal to 32. 2 to what power is 32? 2 to the 5th power is 32. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. All right, log base 5 of 125. All right, what does that equal? 5 to what power is 125? 5 to the 3rd power. We evaluated, we solved. Okay. Let's see. Actually, one more that I like to do. Okay, log base 12 of 1. Log base 12 of 1. 12 to what power is 1? 12 to what power is equal to 1? All right. Anything to the what power is 1. Anything to the power of 0 is 1. So log base 12 of 1 is equal to 0. All right, so we've done our 3 pieces there. We went from exponential to log, we went from log to exponential, and then we evaluated. All right. The next thing is to use the product, quotient, and power properties to expand and condense. All right, so product property, can't see it, let's move it up. Product property, log base 2 of 4 plus log base 2 of 8. First thing is it has to be the same base. You can't add or subtract log base 2 with log base 3. You have to, has to be the same base. So we've got the same base, and so that equals log base 2 of 4 times 8, which is log base 2 of 32. Okay, that's the product property. We talked about that last unit. Quotient, log base 3 of 27 minus log base 3 of 3. All right, when we subtract, well, when we condense, it actually divides. So log base 3 of 27 divided by 3, which equals to log base 3 of 9. All right, there's the quotient property. And I'm kind of moving through this fast because we've already done this. We're just adding in the fact that now there's different bases. All right, the third piece is our power property. Which is 2 log base 5 of 25. Well, what happens in the power property? This comes there. So that would be log base 5 of 25 squared. Well, what is 25 squared? It's 25 times 25, which equals log base 5 of 625. All right, so here this is an example of condensing. We took multiple log statements and wrote one log statement. All right, so we had multiple log statements and we condensed it down to one log statement. All right, the opposite, so this was all condensing. The opposite is expanding, going from one log statement, expand that out. All right, so this was condense. The next is expand, which is expand log base 7 of x divided by y to the third. All right, and so that's going to be, there's one division sign, so that's going to be two different log statements. It's going to be log base 7 of x minus, and this is y to the third, it's going to be 3 log y. All right, now this 3 we could have written as minus log y to the third. If you remember, just right above, all right, if it's 25 squared, that's the same as 2. All right, so this was y to the third, so that 3 comes to the front and becomes 3 log y. Okay, so here we've expanded this out. We took it from one log statement to multiple log statements. All right, so that's condensing and expanding. Okay, the next piece is setting up for the change of base formula. All right, so the change of base formula, I think we probably just need to go to page 363. In our book, on the bottom right-hand corner, there's a table. All right, rather than reconstructing the table, we just need to look at that table. All right, we're going to fill that table out. All right, so you know what I'm talking about. All right, so it starts off with some, you need your calculator. It starts off with some division of logs. All right, and so it does the log of 2, which obviously it's base 10, divided by the log of 2. Okay, and then it's, okay, well, what's the numerical value? The numerical value is 1. All right, and then it has log base 2 of a. So a is our unknown value. All right, well, log base 2 divided by log, or log of 2 divided by log of 2 is 1. And in this column here, we have log base 2 of 2. All right, the next piece down. So first, we're not drawing any conclusions because we only have one piece of information. Log of 4 divided by log of 2. All right, what does that get us when we plug it in the calculator? Log of 4 divided by log of 2, it gets us 2. All right, and then over here, log base 2 of 4. All right, try the next one. Log of 8 divided by log of 2. The numerical value, when we actually do that out, it should give us 3. And so log base 2 of 8. All right, and so what we should be seeing eventually, and that's the one at the bottom, log of n divided by log of 2. All right, that is going to give us log of 2n. All right, so we're taking, both of these are base 10, and now we've got it in a base 2. All right, so we're going this way. We were going here, but we can also go back this way, and that's what's going to become our change of base formula, is if we've got log of base something, here, we can rewrite that as log base 10 of 8 divided by log base 2. So if we've got log base 2 of 90, we don't know how to do that, we could rewrite that, the equivalent statement, as log of 90 divided by log of 2. So in base 10. All right, so more concisely written out, the change of base formula. Can you see where I'm writing? No, you cannot. Change of base formula. All right, log base b, some unknown b, to the power of x is equal to the log of x divided by the log of b. All right, and so this is taking it from some base, putting it in base 10. All right, so let's look at log base 2 of 12. All right. So if we think of that, 2 to what power is equal to 12? All right. Well, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. So 2 to the third is equal to 8, 2 to the fourth is equal to 16. All right, so this goes right past it. All right, so we know that it's somewhere between 3 and 4. It's greater than 3, it's less than 4. All right, and so our equivalent statement here would be log base 12, or log of 12 divided by log of 2. All right, and so we're taking it from base 2 to base 10. All right, and right now that's all we're going to do. We're going from changing the base out of base something we don't like to the more familiar base 10. All right, we can put that in the calculator, but this is a little bit easier. Log 12 divided by log 2. All right, and the actual value, if we did log 12 divided by log 2, should be something like 3.585. All right, but really this is what I'm looking for when we're going, at this point, to take it from a base something else to base 10, because this would be, you could write base 10, base 10. Okay, this is our change of base formula.